All right, today we're jumping into a book with a title that, well, it's designed to get your attention. Evolution Theory is a Blatant Lie by Derek Abishua. Now, whether you agree with that statement or not, our job here is to break down the core arguments the author makes so you can understand his case straight from the source.
And the author is definitely not easing into this. Right from the get-go, he lays out his central claim, and it's a bold one. Evolution isn't just a mistaken scientific theory, it isn't science at all. This one idea is the foundation for everything else in the book, so let's dig into how he builds that case.
Okay, just a quick heads up before we dive in. Our goal here is not to validate or to debunk any of these claims. We're simply here to walk you through the arguments just as the author presents them. Think of us as a neutral guide to the book's core ideas.
So here's the game plan, the roadmap for his argument. First, he starts with philosophy, this idea of a deliberate deception. Then he moves on to the hard evidence, or what he claims is a lack of it, from fossils and biology. After that, he attacks the very engine of evolution, and finally, he wraps it all up by arguing that science actually points to his own conclusion. Let's start with part one. Okay, first up, a deliberate deception. And what's really interesting here is that he doesn't start with bones or DNA. He kicks the whole thing off with philosophy, making the case that evolution wasn't a scientific discovery, but the product of a pre-existing worldview. So that brings up a really key question. Why use such a loaded word like deception instead of just, a mistake? Well, according to the author, that word choice is very intentional. He's arguing that evolution isn't some simple misreading of the data. It's a conclusion that's required by a philosophical belief system, no matter what the evidence says.
And what is that philosophical belief? The author calls it scientism. He defines it as this sort of unwritten rule in science that says you can only consider natural, material causes for everything, period. The book's point is, if you start with that rule, you've already thrown out any possibility of intelligent design before you even look at the first piece of evidence.
So from there, the book lays out this four-step story for how evolution took over. He claims it started with a culture that was desperate for an origin story that didn't need a creator. Darwin came along and provided one, and even though, in the author's view, it had huge problems like a lack of fossils, those were just swept under the rug because the idea was too convenient. Eventually, he argues, it just became untouchable dogma.
All right, so after setting up that philosophical foundation, the author moves to his first major attack on the evidence itself. He calls this section the fossil fraud, and it's all about his case against the geological record.
And what's fascinating is he actually starts by quoting Darwin against himself. He hones in on this line where Darwin admitted that the lack of transitional fossils was the single biggest, most serious objection to his own theory. The book's argument is that, well, that huge foundational problem was never actually solved.
So, according to the book, the fossil record actually shows the opposite of what Darwin's gradual theory would predict. The author argues that the real pattern in the rocks is this. You see complex animals appearing suddenly, already fully formed. Then they stay pretty much the same for millions of years. That's called stasis. And those critical in-between fossils, he says they're just not there. And for him, the Cambrian explosion is the ultimate proof of this sudden appearance.
Okay, so from the big macro picture of fossils, the argument now zooms way, way in, right down to the microscopic level. This brings us to section 3, his argument from what he calls impossible complexity.
Now, the central idea here is a concept called irreducible complexity, and the author uses a really simple analogy to explain it, a mousetrap. You need the base, the spring, the hammer, the catch, all of it. If you take away just one of those parts, you don't get a mousetrap that works poorly, you get a useless pile of wood and metal. It's an all-or-nothing system, and he argues it couldn't possibly evolve one piece at a time.
So then he takes that mousetrap logic and applies it to actual biological systems. His go-to examples are things like the bacterial flagellum, which is like a tiny high-tech outboard motor on a cell, the incredibly intricate sequence of blood clotting, and the whole system that reads DNA and builds proteins. His claim is that all of these are irreducibly complex, and they must have been created fully formed.
So, for the fourth major section of the book, the author takes aim at the very engine of evolution itself. This is his direct assault on the two core mechanisms that supposedly make it all happen: mutation and natural selection.
When it comes to mutations, the book's position is really clear-cut. It claims that every single mutation we have ever observed in a lab or in nature only degrades, damages, or shuffles existing genetic code. He completely rejects the idea that random mutations can create the brand new, functional information needed to build something like an eye or a wing from scratch.
And this leads to what is probably the most critical distinction in the entire book. The author says he has no problem with what he calls microevolution. You know, small-scale changes like developing different dog breeds or beak shapes on finches. He sees that as just observable adaptation. But he draws a hard line at macroevolution, the idea that those small changes can add up over time to turn, say, a reptile into a bird. He calls that pure, unobserved speculation.
And to drive home just how impossible he believes this kind of leap is, the author uses this number, 1 in 10 to the power of 77. That's his cited probability for even a single average-sized functional protein forming by random chance. A number that huge, he argues, is statistically the same as 0. It's just not going to happen.
So what about natural selection? Well, the book reframes it completely. It's not a creative force, he says. It's a conservative one. Think of it like a quality control inspector. It can get rid of the defective products, and it can keep the good ones, but it has absolutely no power to design a new and better product for the next generation.
So, after attacking the philosophy, the evidence, and the mechanisms, all of this leads to the author's fifth and final section. This is where he flips the script entirely and argues that science, when you look at it correctly, doesn't actually undermine creation, it confirms it.
And to make this case, he brings in a real heavy hitter from physics, the second law of thermodynamics. You know, it's the fundamental principle that things in a closed system tend to move from order to disorder. A hot cup of coffee cools down, a sandcastle crumbles. He then argues that evolution, a story of simple things becoming more complex and ordered over time, flies directly in the face of this universal law of physics. And this table is basically his closing statement. He sets up this head-to-head showdown between the two models. For the fossil record, he says evolution predicts gradual change, but the evidence shows sudden appearance. For DNA, he says evolution needs information to come from chance, but what we actually find is complex code. For mutations, for cell complexity, in every single category, he argues the actual observable evidence lines up perfectly with the predictions of creation and contradicts the predictions of evolution.
So to wrap it all up, the book's final argument is this. Evolution isn't a scientific conclusion we get from the evidence. It's a philosophical story we have to believe because of a prior commitment to naturalism. He argues that if you just take off those philosophical glasses and look at the evidence objectively, it points clearly to creation. And he concludes by saying that which view you choose has massive consequences for morality, meaning, and purpose.
And that really is the final thought the book wants to leave you with. This provocative question. What happens when a scientific theory stops being just a testable hypothesis and becomes an entire philosophical worldview? It's a question about the line between science and philosophy and the consequences of letting that line get blurry. Thanks for tuning in.